Hi everyone, welcome to Pre-Calculus. Our first unit this semester is going to be matrices. We are going to learn what a matrix is, how it is used, and all the various operations that we can do with matrices. So we're going to walk through parts of this operations task. We're not going to do the entire thing. So some notes that are actually not included in the task. The actual definition of a matrix is an array of data. In other words, just another way to organize your data. Some very important information is talking about the dimensions of a matrix. We always classify by the number of rows and then by the number of columns. So in this example that we have down here in the right-hand corner, 1, 5, negative 6, 2, 3, 0, you'll notice that I read the elements of row 1 first, followed by the elements of row 2. And the notation down in the bottom, R1C1, represents the element in row 1, column 1, which would be, in this example, a 1. If we had a larger matrix, then we would look at row 3, column 5. So I would go down to row 3 and all the way over to row 5 and state its particular element. So any variable, integer, or combination of the two that you have in a particular space is an element of a matrix. So the first part of our matrix operations task talks about the family snack company that employs these three people, Keys, Zhang, and Troy. It states each of their individual sales for the month of September, and we are going to create a matrix representing all of that data. So we've got to remember all of this as we move on to the next page. So we've got Keys, Zhang, and Troy. And then our first example, this first matrix, they would like us to designate the salesperson's name for the row and the product by the column. You can write each of these out individually, or you can abbreviate if you write big like I do and need to save a little space. So my first person was Keys, and then Zhang is my next person, and the last salesperson is Troy. So right now I've got 3 rows for this matrix, and we'll kick it all the way out here. The products that we had are nuts, and I'm going to abbreviate these. N for nuts, J for jerky, followed by jam. They also sold snack packs, gift packs, and a family pack. Okay, and we're going to list the amount for each person that was sold. So Keys sold 9 packages of nuts, 12 of the jerky. He did not sell any jam, so that's a 0. 16 snack packs, 29 gift packs, and then 8 family packs. We'll do the same info for Zhang and Troy, and this will create our first matrix with this data. So Zhang had 12 sales for the nuts, 4 for the jerky, 24 for the jam, 8 for snack packs, 24 for gift packs, and 12 for the family pack. And Troy sold 12 also for the nuts. He didn't sell any jerky, 12 jars of jam, 36 gift packs. Oh, excuse me. Whoops, that's a mistake. Eek. He also sold 12 snack packs, 36 gift packs, and then 4 family packs. So this is just another way to represent the data. In our next example, now they want us to do the row as the product name and the column as the salesperson's name. Okay, so I had 6 different products. We had nuts, jerky, jam, snack pack, gift pack, and family pack. And then I only had 3 salespeople. And my salespeople at the top are going to be Keys, Zhang, and Troy. And again, we're still going to fill in that same information, but you'll notice our we're going to have the data going vertical for each person instead of horizontal like the last time. So again, it was 9, 12, 0, 16, 29, and 8. Those are the sales for each of the different options that Keys sold. Zhang sold 12, 4, 24, 8, 24, and 12. And Troy sold 12 nuts, 0 jerky, 12 of the jam, 12 snack packs, 36 of the gift packs, and 4 family packs. Okay, so as we compare each of these two, we'll notice it's the same information, but they have different dimensions. So if our matrices are considered equal, they have to have the same dimensions and corresponding elements will be equal. So an example, I would have to have, let's create a 2 by 3, a 2 by 3. So that means 2 rows and 3 columns. So 2 rows, 1, 2, 4, 7, and then 3 columns, 8, 5. Okay, so that is a 2 by 3. In order for it to be equal to another matrix, it would have to have the same dimensions, so it still has to be a 2 by 3, and the same elements. So wherever I put the elements the first time, they're going to be in the exact same spot and be equal to each other. Okay, the matrices that we created in part 1. So in part A, we did a 3 by 6 where we had the people's names in the rows, and then we had the product in the column. And in B, we had a 6 by 3. So it was still all the same data, but we flip-flopped it. Now the products were the rows, and the columns were represented by the salespeople. So these two are not equal because they don't have the same dimensions. So not the same dimensions. There you go. Even though it's the same data, they don't have the same dimensions, so they're not equal. All right, in example 3, now we are talking about the month of October. So we need to classify this data into a matrix, and we're just going to pick one way to do it. It says so. Select one of the matrices from the September sales and do corresponding info. Doesn't matter. Let's do the 3 by 6. Okay. So again, that was the rows by the columns, and the rows represented our salespeople, and the columns represented the product. All right, so we're going to take a step before we get to number 4. So we're going to do September's data. And I need Keys. Oh, no, excuse me. We need October's data. We're doing the next month. What am I thinking? Excuse me for that. October. Okay, so Keys, Zhang, and Troy. And then we had nuts, jerky, jam, the snack pack, the gift pack, and the family pack. I should have squeezed this on the last one, but I didn't have enough space. All right, so in October, Keys sold 8 packages of nuts and 4 packages of jerky, 24 of the jam, 12 of the snack pack, 8 gift packs, and 36 family packs. Zhang sold 16 packages of nuts, 8 of the jerky, 29 of the jam, 16 snack packs, 20 gift packs, and 32 family packs. And for Troy, he did 8 packages of nuts, 12 packages of jerky. What did he have for jam? 4 for the jam, 16 snack packs, 8 gift packs, and he didn't sell any family packs. Okay, so that would be our setup. This is another 3 by 6. And in step 4, it says, create a matrix to display the total number of product sold by each salesperson during September and October. Okay, so total. What does total mean to do? Total just means to find the sum or add them together. Okay, so we need to take a moment, go back to our September data and jot that down again so that we can add those two together. So I'm going to see if I can squeeze it in here. Plus September's data. Ooh, I'm going to have to write super tiny and then get the info in here. So again, keys was 9 and 12 and 0. And then he had 16, 29, and 8. Sorry, this is so tiny, guys. Zhang did 12, 4, and 24. For the first three, 8 snack packs, 24 gift packs, and 12 family packs. And then Troy did 12 of the nuts, 0 of the jerky, 12 jam, 12 of the snack packs, 36 gift packs, and 4 family packs. That's a 4. So if we find the sum of these two things, since we're adding, the order doesn't matter. So the total for each, we're just going to add each element that's in the same spot, row 1, column 1, and add them together. So total, Keys had 17 for the nuts, and he had 16 for the jerky. He had 12 for the jam. He had 28 for snack packs. 29 and 8 for the gift packs would give you 37, and the family pack should be 44, and that is all for Keys. For Troy, we're going to start in, or excuse me, for Zhang, we're going to go row 2, column 1. 16 and 12 will give us 28. 8 and 4 gives us 12. 29 and 24 is 53. Sorry for my yucky handwriting. 16 and 8 is 24. 20 and 24 is 44. And then the last one's 32 and 12 is also 44. And we're under our last guy. Troy, 8 and 12 is 20 for the nuts. 12 and 0 is 12 for the jerky. 12 and 4 is 16 for the jam. 12 and 16 is 28, or excuse me, 16 for snack pack. 28 for gift pack. Snack pack. Gift pack is 8 and 36, which is 44, and he ended up only selling 4 of the family packs. So that's the sum of the September and the October sales for each person. Our next example says create a matrix to show the difference, the change in the sales of each product by each person from September to October. Okay, so you would look back at your September and your October data, and you would just find the difference between these two values. I am going to let you guys do that one on your own, and then you can check your answers with the answer keys. Okay, just a heads up, follow what it says, the change from September to October. So do September minus October. Don't read it the other way around. Okay, I believe that that's how I have my answer. I know that that can be interpreted a little bit differently, so just make sure you follow the way that I've done. All right, as the holiday season approaches, the company expects the November sales to be twice that of the previous month. Okay, so this means for November sales, it's going to be 2 multiplied by the October sales. So what you would do is just very simply double everything that you had in October. So for Keys, Zhang, and Troy, looking at their data, in October, Keys had 8 packages of nuts, so if I double that I get 16. He had 4 of the jerky, so that would be 8. 24 jars of jam, so that would be 48. 12 snack packs would give me 24. 8 gift packs would give me 16 if I double it, and 36 family packs doubles to be 72. So he did a really great job. Zhang had 16 packages of nuts in October, so in November it would be 32. 8 packages of jerky doubles to be 16. 29 jars of jam rolls up to be 58. Holy cow. 16 snack packs doubles to be 32. 20 gift packs doubles to be 40. And 32 family packs doubles to be 64. And last but not least, Troy. His sales doubled as well. 8 packages of nuts doubles to be 16. 12 of jerky will double to be 24. 4 of jam double to be 8. The snack packs double to be 32. They were originally 16. The 8 gift packs doubles to 16, and he didn't sell any family packs, so he still has 0 for the month of November. There you go. This is called scalar multiplication. All you're doing is using the distributive property and multiplying the coefficient on the outside to every single element inside the matrix. That's all that is. All right, so our matrix addition, it can be performed on 2 matrices with the same dimensions by adding the corresponding elements. We don't need another example. We can see the ones that we've done. Multiplication can be done the exact same way. Just distribute your negative through and combine your terms correctly. Scalar multiplication. Each element of a matrix is multiplied by a constant value, or you could call that a coefficient. There you go. So we have finished the lesson. That's all of it. For those of you, you can practice on your own worksheet A, or find any other work online on Khan Academy. That's a great site, or even Delta Math. And here's your quizzes and your practice and your test dates. I hope you guys have a great one. Thanks so much.